Hey there. So you're pretty good at simplifying a single square root, but when you have to multiply two of them together, things get a little messy. Well, you've come to the right place. We're going to make this whole process simple, clear, and honestly, pretty easy.
Here's our game plan. We'll start with a super quick review, then I'll show you a simple three-step process you can use every single time. We'll walk through a tougher example together, I'll point out one super common mistake, and then you'll get a chance to try one on your own. Let's do this.
Okay, first things first. Let's just do a quick refresher on the skill you already have, simplifying one single radical. This is our foundation.
Remember, simplifying is really just about cleaning things up. You're basically hunting for perfect square factors hidden inside that number under the radical. Take the square root of 12, for example. We know 12 is just 4 times 3, and since the square root of 4 is a nice clean 2, we can pull that 2 outside, leaving the 3 behind. So the square root of 12 simplifies down to 2 root 3.
All right, now for the main event. I promise, multiplying these expressions is not some big secret. It's actually just a simple, repeatable three-step process.
This right here is our mantra. You ready? Multiply the outsides, multiply the insides, then simplify what you've got. That's it. You follow these 3 steps every time, and you're going to nail it.
Let's see how fast this works. We've got 10 root 2 times 5 root 3. Okay, step 1, multiply the outsides. 10 times 5 is 50. Step 2, multiply the insides. 2 times 3 is 6. So now we have 50 root 6. Step 3, can we simplify the square root of 6? Are there any perfect squares that go into 6? Nope. So we're done. See, that's all there is to it.
So now that we've got the basic pattern down, let's kick it up a notch and try something a little more complex, one with variables. Don't worry, we're going to tackle this one together.
You know, looking at a big, messy problem can feel a little overwhelming. But think of it like building with blocks. If you handle each piece one at a time, in the right order, it all fits together perfectly. Our 3 steps, those are our building instructions.
And here is our problem. I know, at first glance it looks like a total mess with all those variables and exponents, but we have a process, right? So let's just trust our steps and work our way through it.
Okay, let's break this beast down. First, we group our outside numbers and our inside stuff. Now that first radical doesn't have a number in front, which really means there's an invisible 1 there. So our outsides are 1 and 5. Multiply them together, you get 5. Now for the insides, 2 times 6 is 12. And for variables, remember we just add the exponents. So x squared times x cubed is x to the 5th, and that y to the 5th just tags along. So now we have 5 times the square root of 12x to the 5th y to the 5th. All right, deep breath, final step, simplify. We're hunting for perfect squares. For 12, we can pull out a 4. Now for the variables, here's the trick. We're looking for even exponents because they're always perfect squares. So we break x to the 5th into x to the 4th and a single x. We break y to the 5th into y to the 4th and a single y. Now we pull out all the perfect squares. The square root of 4 is 2. The square root of x to the 4th is x squared, and the square root of y to the 4th is y squared. All of these pop outside and multiply that 5 that's waiting for them. So what's left inside? The 3, the 1x, and the 1y. Put it all together, and our final, beautifully clean answer is 10x squared y squared times the square root of 3xy.
Okay, let's pause and talk about a very, very common mistake. Seriously, knowing how to avoid this trap is just as important as knowing the right steps.
Take a look here. On the left, that's us, doing multiplication. Outsides with outsides, insides with insides. Works like a charm. But look at the right. See that plus sign? That changes everything. With addition, you can only combine radicals if the numbers inside are exactly the same. You can't just add the outsides and add the insides. So 3 root 3 plus 2 root 2, well, it just stays 3 root 3 plus 2 root 2. You can't simplify it any further. So, what's the bottom line? Always, always, always check the operation. The rules for multiplying are totally different from the rules for adding. Don't get them mixed up.
All right, you've seen the process, we've walked through a tricky example, and we've pointed out a common mistake to avoid. Now it's your turn to put it all into practice.
Here you go. Your problem is 4 root 3 times 2 root 6. Just remember our 3-step mantra. Multiply the outsides, multiply the insides, and then simplify. Go ahead and hit pause right here.
work it out, and then press play whenever you're ready to see the solution.
Ready? Let's check it out. First, the outsides. 4 times 2 gives us 8. Next, the insides. 3 times 6 is 18. So now we have 8 root 18. Last step, we simplify. Is there a perfect square hiding in 18? Yes, it's 9. So we rewrite this as 8 times the square root of 9 times 2. The square root of 9 is 3, which comes out to multiply the 8. 8 times 3 is 24, and that lonely 2 stays inside. The final answer is 24 root 2. How'd you do?
So if there's one thing to take away from all this, it's that the order is absolutely critical. You have to multiply everything together first to make one single radical expression. Then and only then can you start hunting for perfect squares to simplify.
So there you have it. You now have the tools to multiply any square root expression they throw at you. Which gets me thinking, if this is how we multiply radicals, what do you think the rule is for dividing them? Something to chew on. Thanks for watching.